can employ the technique of change of variables. Three, we can employ the technique of partial fractions. 4, we can employ the technique of trigonometric functions from identities. 5, we can employ the technique of integration by parts. Again, we can employ the technique of change of variables, substitution, which is the same as the change of variables. Substitution, which again is same as change of variables. Now let's start with the technique number 1, presence of a function and its derivative. Presence of a function and its derivative. We shall look at example 1. Example 1. Integrate x in bracket 3x squared plus 2 raised to the power 4 dx. If you look at this equation, if you differentiate the term in the bracket, then you have 6. You have 6x, which means there's x, 6x, there's x that's also present outside the bracket. So the x outside the bracket is a constant term, and that is the derivative, the presence of function and its derivative. So if you look at the antiderivative of that is dx, and the derivative of 3x squared plus 2 raised to the power 4, which is 3x squared plus 2 raised to the power 5, which will give us 5 in bracket 3x squared plus 2 raised to the power 4 times 6x. This is same as 30x bracket 3x squared plus 2 raised to the power 4. Now, if you look at this equation, you realize that there is similarity between this equation and the one that you are having the one that we are having initially, that is the integrand. The only difference is 30 is a multiple of this 30, and here we don't have 30, and therefore it means the derivative of the integrand, that is ddx, that is the ddx of 133x squared plus 2 raised to the power 4, plus 2 raised to the power 5 is equal to x 3x squared plus 2 raised to the power 4. Therefore, it means the integral of x 3x squared plus 2 raised to the power 4x is equal to 1 over 30 3x squared plus 2 raised to power 5 plus c. That's example 1. Example 2. Example 2. Integrate sine squared 4x cos of 4x dx we note that cos of 4x is a constant term, because if you differentiate sine of 4x, you get a positive of cos 4x. And therefore, there is a presence of a function and its derivative in this equation. So the antiderivative of the integrand, that is d dx sine raised to power 3 4x is equal to 3, which is equal to same as sine of 4x raised to power 3, which is same as 3 sine. So it is same as ddx sine of 4x raised to power 3 is same as 3 sine 4x raised to power 2 times the derivative of sine 4x, which is cos 4x times 4x, so times 4. This is equal to 3 sine 4x, 3 sine squared 4x times cosine of 4x times 4, which is same as 12 sine squared 4x cos 4x. Now if you look at the antiderivative of sine, the derivative of sine cubed 4x is 12x, 12 sine squared 4x cos 4x. There is a similarity between the answer and the integrand, but now the only difference is there is 12 here and there is 12 in the derivative, while the integrand there is not 12. So it means the antiderivative of the integrand, that is d dx, should be 1 over 12 times sine cubed 4x, which is equal to sine squared 4x cos of 4x. It therefore means the integration of sine squared 4x, sine squared 4x cos of 4x dx is equal to 1 over 12 sine raised to power 3 4x plus c, constant term. Let's look at another example. Example 3. Integrate x in bracket x squared plus 1 raised to power 2 dx. Now this also there's a presence of function and its derivative, because if you differentiate the term inside the bracket, you will have 2x, while outside the bracket you have x, which is the constant term, and therefore we employ the technique of presence of function and its derivative. Now the antiderivative of x bracket x squared plus 1 raised to power 2, that is d dx, x squared plus 1 raised to power 3 will give us 3 in bracket x squared plus 1 raised to power 2 times 2x, which is equal to 6x in bracket x squared plus 1 raised to power 2. Now, if you look at our answer, you find that the similarity between this equation and the integrand. The only difference is the term 6, and therefore it means the exact antiderivative of the integrand is d dx 1 over 6 in bracket 6 squared x squared plus 1 raised to power 3, which will give us x in bracket x squared plus 1 raised to power 2. Therefore, the solution of integration of x in bracket x squared plus 1 raised to power 2 dx is equal to 1 over 6 in bracket x squared plus 1 raised to power 3 plus the constant terms c. Example 4. Let's look at example 4. Example 4. Integrate 2x plus 1 raised to power 4. Integrate 2 raised to power integrate 2x plus 1 raised to power 4 dx. The antiderivative of 2x plus 1 raised to power 4 is dx 2x plus 1 raised to power 5. If you differentiate 2x plus 1 raised to power 5, we have 5 into bracket 2x plus 1 raised to power 4 times 2, which is equal to 10 in bracket 2x plus 1 raised to power 4. Now, if you look at our answer, there is a similarity between 10 raised to power 10 in bracket 2x plus 1 raised to power 4 and the integrand, which is 2x plus 1 raised to power 4. And therefore it means the derivative of 1 over 10 in bracket 2x plus 1 raised to power 5 is equal to 2x plus 1 raised to power 4. the solution of the integration of 2x plus 1 raised to power 4 dx is 1 over 10 in bracket 2x plus 1 raised to power 5 plus the constant term c. Another example, example 5. Integrate x squared root of x plus 3, x raised power 3 plus 1 dx. Now this can be written as integral of x squared in bracket x raised power 3 plus 1 raised to power half dx. Now if we differentiate the term in the bracket, realize we get 3x squared, and there's also the presence of x squared outside the bracket, and therefore there's presence of a function and its derivative. So it means that if we differentiate, or if we look at the antiderivative of the term in the bracket x squared, x raised power 3 plus 1 raised to power half, that is d dx x cubed plus 1 raised to power 3 over 2 will give us 3 over 2 in bracket x cubed plus 1 raised to power half times 3x squared, which is equal to 9x squared over 2 in bracket x cubed plus 1 raised to power half. Now if you look at the solution to our differentiation here, you find that there is similarity between 9 raised to power, 9 over 2x squared bracket x raised to power 3 plus 1 raised to power half and the integral term. The only difference is that there is a multiple of 9 over 2. It therefore means if you differentiate 9 over 2 times x raised to power 3 plus 1 raised to power 3 over 2, you have x squared in bracket x raised to power 3 plus 1 raised to power half. It therefore means the solution of the integration of x squared root of x raised to power 3 plus 1 in bracket dx is equal to 2 over 9 in bracket x cubed plus 1 raised to power 3 over 2 plus c. Example 6. Example 5. Integrate x squared root of x plus 3, x raised to power 3 plus 1 dx this can be written as integral of x squared in bracket x raised to power 3 plus 1 raised to power half x. Now if we differentiate the term in the bracket, realize you get 3x squared, and there's also the presence of x squared outside the bracket, and therefore there's presence of a function and its derivative. So it means that if we differentiate, or if we look at the antiderivative of the term in the bracket x squared, x raised to power 3 plus 1 raised to power half, that is dx x cubed plus 1 raised to power 3 over 2 will give us 3 over 2 in bracket x cubed plus 1 raised to power half times 3x squared, which is equal to 9x squared over 2 in bracket x cubed plus 1 raised to power half. Now if you look at the solution to our differentiation here, you find that there is similarity between 9 raised to power, 9 over 2x squared in bracket x raised to power 3 plus 1 raised to power half, and the integral term. The only difference is that there is a multiple of 9 over 2. Therefore means if you differentiate 9 over 2 times x raised to power 3 plus 1 raised to power 3 over 2, you have x squared in bracket x raised to power 3 plus 1 raised to power half. It therefore means the solution of the integration of x squared root of x raised to power 3 plus 1 in bracket dx is equal to 2 over 9 in bracket x cubed plus 1 raised to power 3 over 2 plus c. Example 6, this was example 5, example 6. Example 6, integrate sec squared x tan x dx integrate sec squared x tan x dx. Again, there's a presence of a function and its derivative, because if you differentiate tan x, that is tan 2x, which is same as d dx, which is same as 2 bracket tan x times the derivative of tan x times the derivative of tan x and dx of tan x, which is same as ddx sin x over cos x. If you employ the technique of quotient rule of differentiation, that is, say, let this one be u, let sin x be u and cos x be v, then we will have v du minus u dv over v squared u dv. So v du, v is cos of x, du derivative of sin x, which is positive cos x, minus u, that is sin x, and times derivative of v, that's derivative of cos x, which is minus sin x, over v squared, and v squared is cos squared x. Now this is same as cos squared x plus sin squared x over cos squared x. The numerator gives us 1. Cos squared x plus sin squared x is equal to 1 over cos squared is equal to 1 over cos squared x. So the derivative of tan x, the derivative of tan x, the derivative of the ddx of tan x is 1 over cos x. 1 over cos squared x. So we can substitute here 1 over cos squared x. So in other words, we're saying ddx of tan squared x is 2 tan x times 1 over cos squared x. 1 over cos squared x is same as secant squared x. So this is sec squared x. Now there is a similarity between our solution, between our answer and the integrand, because there is sec squared x, tan x and tan x. The only difference is 2. Therefore, it means to make it to be exact, we need to divide the derivative of tan x by 2. So ddx half tan squared x is equal to sec squared x tan x dx. Sorry, it's equal to sec squared x tan x. It therefore means the integration of sec squared x tan x dx is equal to a half tan squared x plus the constant term c change of variable technique, change of variable technique, or substitution method. We can use example 1 to demonstrate the change of variable technique. Example 1. Integrate x in bracket 3x squared plus 2 raised to power 4 dx. In the change of variable technique or substitution method, we can let solution. We can let y is equal to integral of x 3x squared plus 2 raised to power 4 dx du dx over du times du. Again let u is equal to 3x squared plus 2. Therefore means dx is equal to 6x. This is equal to 6x. Therefore it means dx du is 1 over 6x. So you can say this same as saying integral of x u raised to power 4, because 3x, we have let 3x squared plus 2 is equal to u, so it's u raised to power 4. dx du is 1 over 6x times 1 over 6x du. X cancels with x. And therefore we have integral of u raised to power 4 times 1 over 6 du. This same as 1 over 6 outside the integral. 1 over 6 integral of u raised to power 4 du, which is equal to 1 over 6 u raised to power 5 over 5 plus the constant term c. But remember we say u is equal to 3x squared plus 2. Therefore means we have 1 over 6 times 3 raised to power x, 3x squared plus 2 raised to power 5 times 5 over 5 plus c, and that is equal to 1 over 30 times 3x squared plus 2 raised to power 5 plus c. You realize the answer is the same as the one we got when we used the method of the first method of by just recognizing the presence of a function and its derivative. So it means the solution of integral of x in bracket 3x squared plus 2 raised to power 4 dx is 1 over 30 x 3x squared plus 2 raised to power 5 plus c. Example 2. integrate sine squared 4x cos of 4x dx. Solution, you can say let y is equal to integral of sine squared 4x cos of 4x dx, dx du. Again, we can let u is equal to sine of 4x. Because if you differentiate sine of 4x, you get cos of 4x. Du, therefore du dx is equal to positive cos of 4x times 4, which is equal to 4 cos 4x. Therefore dx du is 1 over 4 cos 4x. So this same as saying integral of u is equal to sin 4x, so this is u squared cos of 4x. Dx du is 1 over 4 cos of 4x du. Cos of 4x cancels out with cos of 4x. Therefore, we have integral of u squared times 1 over 4 du, which is equal to integral of 1 over 4 outside the integral, u squared du, which is equal to 1 over 4, u raised to power 3 over 3, plus the constant term c. But remember u is equal to sine of 4x. Therefore, the answer is 1 over 4 sine of 4x raised to power 3 over 3 plus c, which is equal to 1 over 12 sine raised to power 3 4x plus c. That's the answer.